So my name is Mandeep, Mandeep Singh Sandhu. I've been with Palo Alto Networks for about a little over 5 years now. I started as an escalation attack engineer based out of Amsterdam, worked there 3.5 years, then moved to the United States. And I've been a product manager for App ID for the last 1.5 years now. So we are here today to talk about data center best practices. Now, when it comes to best practices, data center is a little unique. It's a very dense topic. There's a lot of moving parts. It's extremely crucial to the survival of a company. And it's very important to identify attackers if they're in a data center, or to protect your sensitive assets, and to limit or stop even the lateral movement. And that's what we will talk about today. The agenda of the slide deck is going to be, this is a very prescriptive approach that I'm going to preach here today for data center best practices. We will go into a lot of details. We will have a lot of snapshots from our UI. We'll have a lot of animations also to make sure that everything that I'm presenting is clear to the audience at the back too. Hopefully we'll be able to cover this in the next 45 minutes, and then we will try to give ourselves like 5 to 10 minutes for Q&A at the end. Sounds good? Okay, let's start. So why do best practices matter for a data center? One of the very important reasons is something called CIA as an abbreviation. And it's not the investigative agency. This means confidentiality, integrity, and availability, which are like, it's called the key triad of running a data center. For anything that exists in a data center, you have to maintain confidentiality, you have to maintain integrity, and you have to make sure that these resources are available to users and to everyone else. Another aspect is the rising cost of a data breach. Now, a data breach does not only cost you money. There's a cost related with the reputation, the integrity, the trust customers put in your organization. And anytime there is a breach, as we have seen in the news in the past few years, there's an erosion of this trust, which leads to even further loss of revenue. And sometimes, depending on the size of companies, they can even cease to function. Very important point, next one, is the evolving threat landscape. As we have seen over the last few years, the threats have evolved. They have become more persistent, they've become smarter, and they become even harder to detect. In the light of these, it's extremely important that the data center best practices also keep up and they evolve. The next point, compliance. All data centers must go through some sort of compliance. These compliance needs also drive some best practices, because you want to make sure you're compliant to these certifications, and customers trust their data that resides in this data center. So now that we have understood why best practices matter, let's go to the heart of the matter. And let's talk about some goals and methodology on how you will go about implementing these best practices, right? So there are 3 high-level goals that we have here for data center best practices. One is, we want to, of course, secure your most sensitive assets. And we'll take a look at that in the next slide. How do we go about doing that? Identifying assets. We want to stop the lateral movement. If there is an attacker inside, we want to limit it as much. In fact, to some extent, we want to stop it and even identify attackers. So the third is identify attackers, of course. And these 3 goals tie back into what you would have noticed in a lot of sessions over here, what you would have also noticed in the keynote that Lee Claridge gave yesterday. Goes back to 4 key founding pillars of these best practices. First of which is complete visibility. Second is reducing the attack surface area using this visibility. Third, of course, is you prevent the known threats. And the fourth, very important pillar is you prevent the threats we don't know about, the unknown threats. So how do you do identification of assets? So this is more of a problem where we want to organize all your assets that you have in the data center into distinct buckets so that you can visualize and you can understand, okay, how am I going to go protect these one by one? So you have your crown jewels, which are the most important, and then you have some other valuable assets, and then we basically have some other remaining assets that we go tackle. The crown jewels are key aspects that are so pertinent to your business that without them, the business cannot run. These could be your patents, your intellectual property, formulas if you're a pharmaceutical company, code base if you're a high-tech company like ours, PKI, your entire public key infrastructure, Active Directory. If any one of these is compromised, it's the biggest hit you get on your business. After that, you have your critical IT and business assets that you also want to protect. You have very important file servers that store a lot of information. You have databases. You have your email servers. A lot of companies these days practice the policy of actually deleting all emails after they're a year old. Why do you think they do that? Because you don't want your emails to end up on the internet of conversations between the C-level executives, right? So email server, of course, is extremely, extremely important to protect. And then you basically take this approach and you iterate it on the remaining assets. Once you have done that, you have at least come to a phase where you now know what your assets are. The next step in the data center puzzle is understanding flows. In a gateway kind of a situation, it's fairly straightforward. There is north-south, there's user population going to the internet, and we are going to have best practices for that, which we just covered in the last section. However, when it comes to data center, things have been changing. And when I say things have been changing, the data center has been evolving. Now let's look at how it has evolved. So many years ago, maybe when I was still in grad school, this is what the data center looked like. You had a room where you would go in, and there's a rack of servers, and there's cables everywhere, and this is your data center, and this is what you have to protect. Then virtualization took off. We got the private cloud. So now you had some physical, some virtual. Well, then came the cloud. AWS, Azure, even Google Cloud. Now your data center exists in the cloud. It exists on-prem. There's a private cloud, and there's some SaaS applications. So now, essentially, you're in a hybrid model. Pretty much most customers today sit in a hybrid model. So in this hybrid model, there's 4 fundamental flows that will drive our discussion through the rest of this session on how we go about implementing best practices. The most common flow in a data center, of course, which is the most amount of traffic also, is the users going into the data center. Then the next flow that we have is the data center resources going out to the internet. Sorry, this is the other way around. This is the internet actually coming into the data center. The flow after that is the data center resources going to the internet. And the last flow is the intra-data center traffic. So there is east-west movement of traffic within the data center. Now hold on to these 4 flows, and we'll come back to them after a few slides, and we'll go through each one of these flows in detail to understand best practices. So let's talk about some groundwork that has to be there before we get to implementing best practices in terms of security policy, right? The first is something we call segmentation. So you would want to move from this place where all the users and all the data assets are in two separate kind of zones, or you can call it subnets, you can call it VLANs, to something like this, which means that we implement the zero trust security model. This means that every user has its own zone, every type of user population, every type of data asset has its own zone, and attacks from one are limited within that specific VLAN segment or IP subnet or zone. And once we create this, then it becomes a lot easier to write proper policies and go towards those best practices. There's a lot more detail that will be covered in this session just on that aspect, on the aspect of plumbing in the data center. So don't miss this session. So now we have our foundation covered, right? We have a fairly good idea on what we want to protect. Remember those 3 buckets? Then we have a good idea of what are the 4 flows in a data center. So you have users to DC, internet to DC, DC to internet, and intra-DC. And then, of course, we have done the segmentation. Now, given those ground rules, principles, let's look at some of the deeds or the policy building that we'll do. So the format we have here is that to make it easy to understand, we will first go through some of the common security constructs. These are security constructs that are relevant to every single data center flow out of those 4 flows. They are threat prevention. These are your security profiles. We'll go through each one of those, and we'll see how you configure them. SSL decryption. Sometimes a controversial topic, right? But extremely relevant to best practices. And of course, logging. So let's talk about threat prevention. Vulnerability protection profile. So what we advocate is that we have something called a strict vulnerability protection profile on the firewall. So we recommend that you take this profile and you basically duplicate it, clone it, and make the changes that we have suggested here. And this profile gives you protection from buffer overflows, from server vulnerabilities. Once you've done that, you go to the next profile, which is the antivirus profile. Here also, we recommend you clone the default and you modify the highlighted part. So notice here that there's something also called a wildfire action. So this profile is the profile where all the intelligence that is pushed from wildfire, let's say if you have 5 minutes wildfire content updates, this is how that intelligence is enforced. Anti-spyware profile. Here also we recommend that you clone the strict anti-spyware profile and you modify the highlighted selections. The highlighted stuff, what we are saying is that how it moves, right? So it changes from what we have as default and we make it a little more aggressive here. Anti-spyware profile is giving you protection against all types of command and control traffic. It's also used to exfiltrate data. So it'll protect you against those. And there is 2 parts in an anti-spyware profile. So this is the first tab, but we'll also talk about quickly something called DNS sinkholing. Extremely relevant on identifying attackers. If you have systems in your user population that have been compromised and there is C2 activity going on from these systems, this feature can actually help you identify those attackers. Next, we look at the file blocking profile. Now, this is one of a black sheep of the security profiles, right? Because there is no signatures here, but this is a key profile that you use to reduce the attack surface area, and it's extremely fundamental in this approach. So what we recommend here is that you use the default file blocking profile that we have, where we have blocked all the risky file categories. You might have to take a better look at exe. Depending on your situation, you might or might not want to, block it. You would block it in some cases, but whereas allow it in some. The next is, there is 2 more categories where we suggest you to do this, to log all other file types and prompt for the other ones. And after we have gone from file blocking profile, we move on to the wildfire analysis profile. This is with what we cover the unknown attacks. And we'll talk about how these different profiles fit in each one of those 4 data center flows. Next topic, SL decryption. Now, SL decryption is very relevant. The first part that we really suggest is the protocol settings part on the decryption profile. So this is where we recommend that we set the TLS versions between a min and a max version. So what I've suggested here is to use 1.1, even though 1.1 has been around for now 10 years and it's fairly old, but we still continue to see systems that are using this. Do not select the minimum version as SSL v3, please. And the max is kept as max because in case there's a newer version of TLS that comes up, you guys can continue to use it. We suggest that you do not use the encryption algorithms that have been thoroughly compromised. We suggest you do not use the authentication algorithms that can be compromised, the ones that are highlighted. Once you're configuring the decryption profile, there is also something called the no decryption settings. So essentially, you can write a policy where you're saying, I don't want decryption, but I still want some protection against expired certificates or untrusted issuers. Inbound inspection, you implement the same concept. Important thing to keep in mind is inbound inspection for non-PFS sites will always give you better performance than forward proxy. Forward proxy, block sessions with expired certificates. All those checkboxes marked. This is what we recommend. Now, this is covered in a lot more detail in this session. So the third common security construct was logging, which we talked about, right? So how do you identify attackers? So there's something called an interzone default policy at the bottom of every firewall, of every panorama. What we suggest is you go to that policy and you do override, and you select something called log at session end. This will give you visibility into anything that's getting denied, but it'll get logged. You can send these logs to your SIEM, you can do analytics on these logs. Really helpful to identify attackers. So, now that we have gone through the common security constructs, let's go back to those 4 flows, right? Let's go back to the most common flow of all. User segment to data center. So what kind of threats can exist in this kind of a flow? So you have your user population at the bottom going to your on-prem private cloud data center or your public data center. One of the biggest threats that we see is malware propagation. If one user gets infected, and we are not implementing best practices, that malware will propagate to all your resources in the data center to different users. So what's the right approach? How do you protect yourself from this? So of course, we have the 4 key aspects of the 4 founding pillars that we looked at in the beginning. The binoculars give us the more visibility. So you get better visibility through these aspects. You do inbound inspection for decryption. You implement user ID. You use app ID. Anyone can tell me why we didn't put forward proxy here in decryption? Because if your users are going into your own servers, you don't need forward proxy decryption. Typically, when we mention decryption, everybody starts thinking forward proxy, and then the discussion doesn't go anywhere because there's a performance limitation and this and that. So for your most common traffic pattern in a data center, you actually can just use inbound inspection and get all the benefits of decryption. Okay, now you get this visibility, and how do you reduce the attack surface area? You whitelist applications. You whitelist users. You use dynamic address groups. Something really cool that came out in Palo S8, authentication policy. We'll talk about all of this. And of course, you use the strict threat prevention profile that we have looked at, right? Which are all the profiles that we looked at. So how do we put it all together? So what I have shown here is an example policy, just to illustrate how this all works. Now, this is not exactly representative of your situation, but this is just a representation that we are trying to accentuate on the concept that we presented. So we have a policy here, as you can see, where we have tagged it, of course, and in your user population, there is engineering resources. Let's take the example of Palo Alto Networks, for example, right? We have our engineering people, and they want to access some servers that they write code on, right? Let's say we are using Perforce. So we use user ID here. We put them in the user column. We use destination-based controls, so we use dynamic address groups there. Dev servers and SAP servers. There's an engineering population. There's contractors that are accessing SAP. They should have different levels of treatment. We whitelist applications. Sorry. Perforce, MS SQL DB, SAP. And we use the service as application default. What we highly, highly recommend is never use service as any. Either use application default or use custom service objects. And then, of course, we use all the threat-based profiles that we mentioned, that we just discussed. So these are the AV, these are the anti-spyware vulnerability profiles, right? And they're giving you protection against all different types of attack vectors. If there's a user that is compromised and he's uploading files, we are using the file blocking profile in those profiles to limit what kind of files he can share. We are also using wildfire analysis to make sure that all these files are being sandboxed. One of the assumptions we have typically seen customers make in user to data center kind of flows, the legacy approach typically has been that you don't need sandboxing. Well, you do. Then this is the decryption policy that we suggest. You have your source users here as well. And we are implementing inbound inspection. And one more thing for this flow. Authentication policy. So Lee talked about this in the keynote yesterday. We launched this feature in Palo S8. This gives you extreme flexibility for securing applications that you have in your data center. Without even changing the application, you can enable MultiFactor Authentication. And you can do that in the same way that you do with other policy constructs. You can make it user-based. You can define your destinations. You define your services. These are not applications, by the way. They look like applications, but these are your custom service objects that I've created. All these users from engineering, when they're getting to these resources, if there's a developer logging into Perforce, before he logs into Perforce, he'll be challenged with a second factor. And actually, you can define timeouts. You can actually define timeouts where you can say that if a developer has logged into a Perforce server, I can only cache this mapping on the firewall for a minute or 10 minutes. After that, I want him to, again, do two-factor. More details in this section. We have a dedicated session for preventing credential theft and abuse. Let's go to the other flow. Internet to data center. So what kind of threats can exist in this flow? So you have traffic coming in from the internet going into your data center resources. Let's say you're hosting a web server. It can be an excellent target for something called a waterhole attack, where someone will compromise that server, and whoever accesses that web server on the internet keeps getting compromised. You might also have a server vulnerability in one of your servers that's going out to the internet that can be exploited. To protect against these threats, what is the approach that we recommend? How do you get visibility for this? You enable decryption, inbound inspection. So this is your web server. This is your website, right? Extremely important resource for you. It's key to the running of the business. And you can do inbound inspection there to get into visibility on what's coming in. You use App ID. How do you use those concepts to reduce the attack surface area? Let's look at that. You whitelist applications. Geolocation-based policy. You only want to allow access from regions where you want users to access. Actually, it's easier to do the opposite, and that's what we will go through in the policy. For places where you do not want users to have access from, you don't. External dynamic lists. We discussed this in the preceding session also. So we ship these template dynamic lists that exist on the firewall that basically you can go about and use directly in the policies. External dynamic list is a very, very strong and very flexible way of giving you source and dest-based controls. You also implement the protocol settings tab that we looked at the very beginning for SSL decryption, right? And of course, we use these profiles. You use strict anti-spyware, strict vulnerability, strict AV, file blocking, and the wildfire analysis profile. That gives you protection against unknown threats. How does this come together when we configure policy? Let's look at that. So this is a security policy which we are writing to protect resources residing in a data center which are being accessed from the internet. So as you can see, in the source-based controls, we have done a negate on a bad IP list. Anything that's coming from this EDL, external dynamic list, please don't allow it. No access from North Korea. Destination, only to my web servers, right? You write an address script for that. Next, you write applications. So here you actually, so the Acme app that I have put there, the application is a custom application that I have written because I'm hosting this web server. I know everything about this web server, what the certificate looks like, what the URLs look like. I'm in full control, and I have all the information I need to write a solid custom app that will only allow access to the server. It's very common that when we talk to customers about custom app ID, the process seems a little esoteric. But we have fairly good documentation that you go through, and the benefit that it gives you, the protection it gives you, is totally worth the time you will invest into it. In the other policy, in the second policy, the applications that I've shown are SSL web browsing. Maybe you would want to allow some level of access for these applications. And you lock this down using the URL category. So if you see in the second policy, I'm allowing access to SSL web browsing from internet to inside. But at the same time, I'm using URL category, and I'm blocking those bad categories. And I've actually created a custom URL category called My Web Server, which means that I'm only allowing access to my web server for anything which is SSL and web browsing. Fairly locked down policy. And of course, last but not the least, we use all those common security constructs that we mentioned in the beginning. Strict AV, strict vulnerability, file blocking, wildfire analysis, anti-spyware. That's where all our threat intelligence gets fed into. Along with this, you'll have a decryption policy where you'll use the same controls to do inbound inspection. So I've graded this out because there's another key aspect which is very easy to forget when we talk about this data center flow. DOS attacks. So you can actually write a DOS protection policy where you can basically configure the DOS protection policy to protect you. The reason I have crossed out bad IP and KP is because you anyways have written a security policy which does not allow access from these sources. So there is no reason to do DOS protection because all this traffic will never establish any session. Of course, you're taking care of your destination servers. You're trying to protect these two services. And you've created a DOS protection profile, and you have implemented into a policy. Now let's look at the next flow, the opposite of internet to data center. Data center resources going out to the internet. What are the threat vectors here? Data exfiltration. If any one of the servers is compromised in the data center, that can be used to exfiltrate data. In an attack that's maybe 3 years ago, without naming anybody, FTP was used to exfiltrate data out. Lots of credit card information was lost. Malware download. So even though the flow is data center internet, but if some resources like servers are visiting, going to some services, and those services are compromised, the malware can propagate. What is the right approach? For visibility, we suggest you implement decryption. This is where forward proxy comes in. We use app ID, and we use that visibility to whitelist applications. And this is where URL filtering is very, very relevant. When your servers in the data center are accessing resources to the internet, you don't want them to go to the likes of phishing, malware, proxy anonymizers. You want to block all those categories. Dynamic address groups. You want to use those to be more nimble and flexible in what services access the internet. Along with that, you use all the threat profiles. Now let's see how this looks like in a policy. So we write a security policy where we have a dev server sitting in the DMZ, and it has to go to the internet to get some Microsoft updates. Right? Very common use case. So we whitelist the application here. MS update. SSL. Only on application default ports. Microsoft does an excellent job of listing out URLs and IPs for the resources. I wish all SaaS-based companies would do that. Like, they have amazing resources when it comes to protecting Office 365. They publish the entire list of IPs and URLs. They actually do the same for their update services. With that information, it becomes extremely easy to construct a policy which is fairly narrow. So now what you're saying here is that for this policy, only allow these URL categories. So I have created custom URL categories which go like star.windowsupdate.com, update.com. You get this entire list from Microsoft. No other traffic will go. And on top of that, given that I'm decrypting, I have visibility into the threads. I'm also using the thread-based profiles. For the decryption policy, you use the same concept. I actually had a question in the last session that how do I create a decryption policy which I want it to be very specific? So there's multiple ways of doing that other than source and desk-based IPs. One of them is using URL category. So the same custom URL category that we created and we are using in the security policy, you can directly use the same custom URL category in a decryption policy, and it will only decrypt traffic going to these URLs. And you get those URLs based on the SSL client, SNI, from the handshake. So this gives you a fairly narrow decryption policy, which should alleviate any concerns regarding performance, because decryption does take performance. So we implement forward proxy in this case and apply the data center best practices profile that we discussed in the very beginning. The next flow, which is our fourth flow, intra-data center. It's hard to see arrows in this flow, and I did that with a purpose. It's also hard to find attackers in this flow because we make a lot of assumptions that if it's within the data center, it should be fine. I want operational efficiency. I do not want anybody telling me things are not working. So I want everyone to have access to everything within the data center. Only if they're going out or in, I want to be a little careful. But that is the traditional wrong approach, right? East-west is a large amount of traffic. A large amount of it is actually encrypted. Some amount of it is not encrypted. So it's essential to have visibility into this traffic too. So if you see those small arrows on the top, the app server might be talking to the dev server, right? And this is one of those flows, and I wanted to spend a little more time on this, is because it has evolved so much over the last few years as applications have evolved. So first we had the single-tier applications, then came the two-tier, and then we have multi-tier applications where there's a web server that wants to talk to an app server, and then the app server is further talking to the database server. Classic example, you're booking a flight ticket, right? You go on there, the web server talks to the app server, gives you some information, then you submit your credit card details, then in fact, there's a flow that's also going out to the internet, but at the same time, there is something that is being accessed in the database servers. So there are these multitude flows in this east-west, and it's extremely relevant to protect all these. Because if you don't, then an attacker comes in, he can move laterally. He can jump from server to server until he's successful. Going back to the keynote yesterday, going back to the topic of unsupervised machine learning, this is where light cyber is extremely relevant. So do attend those sessions. We're not talking about that in detail here, but that gives you more protection in these situations. And once an attacker does that, with lateral movement, they can repurpose servers. Once the server is completely repurposed, it's completely owned by the attacker, and they can do anything they want with that. They can extract whatever information without even anyone knowing about it. So what is the right approach here? Yes, decryption again. You have to use it. There's a considerable amount of traffic that we still see encrypted in data centers. You would want to use forward proxy there. We also recommend using custom apps. Along with that, the same concepts that we discussed. We have custom app ID, we have the protocol settings, we have dynamic address groups and whitelist applications. One thing missing here is users. Because these are servers accessing servers. And of course, we recommend that we implement all the strict threat prevention profiles here. So how does this look like? Let's double click on that. So I have two examples here. We have an app to the database server, three-tier application. One of the examples of three-tier application could be WordPress, known for vulnerabilities, but it's a very common application. SharePoint, if you still have an on-prem SharePoint server, you'll typically have the SharePoint server talking to the AD server, you'll have the SharePoint server talking to your MS SQL DB server, and same applies to the WordPress servers, right? So I have here an app to DB server and a web to app server. Okay? How do we go about? So we write dynamic address groups on the source address. These addresses should be known, right? So we write policies for that. Then we combine it with desk-based controls, which are the zones, of course, but also the address groups, where we are limiting communication between this data center based on source and desk-based IP addresses, which are, again, more flexible because we are using the dynamic address groups. So the billing app server is having an access to the DB2 servers and the SQL database in the first policy. In the second policy, the web servers are accessing the app servers. What applications are we protecting? Well, I wrote a custom app for my billing application because it's my own application. I know how exactly this application works. I know exactly how it looks like on the wire. So I can write a fairly good custom app. On top of that, I know which databases I'm using. MS SQL, maybe I'm also using DB2, and SSL. I'm enabling this on application default ports. In addition to that, I'm using all the thread-based profiles. The vulnerability will protect you against server vulnerabilities. Anti-spyware will catch any command and control communication in these workflows. File blocking will limit what kind of files should move between these servers. Should there be binaries moving between these servers? Should there be EXEs moving between these servers? Should there be even a PDF moving between these servers? All those controls. Wildfire analysis profile. I actually want to take all these resources and I want to send them to the cloud to get intelligence. This is how the decryption policy will look like. So it's a fairly narrow policy where you're using source and desk controls again. And you're doing forward proxy decryption using the data center best practice decryption profile. So what do we conclude now based on these 4 floors discussion? So what we have seen that the data center has evolved. This is where pretty much everyone today is in the state, where there's different parts in the data center. There's the on-prem, private cloud, public cloud. Given we have that, there's 4 flows. User to data center, internet to data center, internet, intra-data center. And all in each of those 4 flows map back to the same basic constructs, which are these: complete visibility, reduce attack surface area, prevent the known threats, and then prevent unknown threats. With this approach, we are fairly confident that if you go back, look at your data center, map out the flows, map out the assets, and then go step by step, you can be in a fairly good shape. There's resources that we have along these. We have a fairly thorough documented guide that we have put out, the link to which is shown there. In one of the booths, we also have, we can have a fairly good discussion with there's a heat map kind of tool that our customer success organization has put, where you can constantly check how far along have you implemented best practices. So that's all about data center best practices. We actually have 4 minutes to 5 minutes for Q&A, and I'll be waiting back here even if there are more questions after those 5 minutes.
Okay. Question regarding intra-data center traffic. Do you recommend that, or do you feel it's a best practice for systems within the data center to encrypt or not encrypt their own traffic, since encryption has to be decrypted to get visibility, and how would that compare to public cloud?
So the question is, for servers or data center resources that are communicating intra-data center, east to west, is it recommended to enable encryption? So it depends on the kind of servers you have. If you have sensitive data that is being moved, you should still use encryption. But at the same time, you should have some capability to decrypt and have some visibility into those workflows. Whereas in some situations, you know that the traffic that is moving back and forth between these servers, it's protocol information, but there is nothing too sensitive there that can be used against you. And in those cases, maybe you don't have to, right? Any other questions? So I have one over here, one over there. Okay, so let's go on that one first, sorry.
Yeah. For intra-DC traffic, you know, that's a lot of traffic to forward through a single firewall or anything. What is the best practice as far as getting that traffic through the firewall, and where does the, you know, where does the core switch and routing come into play?
So the question is that in intra-DC environments, there's a lot of traffic that's moving back and forth, and how do we ensure that all of this traffic is actually passing through a firewall, or how do you go about what should pass through a firewall and what should not, right? Okay, so for that, there is actually a dedicated session that we have. I mentioned about it briefly in the section. I think it all goes back to what are the most important assets that you want to identify and protect. What are you trying to protect? What are you protecting against? And it's hard to find a single answer to that question, I think. But there's a lot of plumbing that we have covered in the other section that might be relevant to you. And you can always find me in the booth, and we can go through that. That's a fairly dense question, but thanks. Yes?
So I wanted to ask you about the difference between the forward proxy and the inbound inspection for the SSL decryption.
Sure.
So I know the forward proxy would terminate that SSL. Does the inbound have less of that? I thought I heard you say that it had less overhead on decrypting that traffic. Did I understand you correctly?
Yes, that is correct. So the question is, how does forward proxy compare to inbound inspection in terms of performance, in terms of how exactly it works? Forward proxy is that, of course, we are terminating the SSL session in either direction, right? And there is a performance difference from not decrypting. Now with inbound inspection, if the web server is not using PFS, which is perfect forward secrecy, which means if it is not using elliptic curve, Diffie-Hellman kind of cipher suites, then we do not proxy, because we do not have to. Because what you do is you take your server, you take the certificate and the private key, and you move it to the firewall. The connection is still between the client and the server. We are just sitting in the middle. We have that information, so we are decrypting it on the fly. That is why the performance in inbound inspection is a lot better than forward proxy. You can go to our datasheet numbers, and we actually split it like that, and you can see that. Now, however, since PFS is becoming more common, with that, things change. When we have the likes of elliptic curve algorithms, we actually have to proxy because there is no other way we can decrypt, because when you do not use RSA as a key exchange algorithm, the key does not stay the same. It keeps changing. So there is no way you can keep moving keys back to the firewall. That's not a static private key. It's ephemeral, which is why there will be a proxying there, and the performance might be somewhat closer to forward proxy in that sense, but I think datasheet numbers have those numbers. Did I answer your question? Okay, thank you so much. Okay, we have one more here.
The question is around the different profiles that we can attach to any specific firewall rule. What is the impact on performance and throughput? So do we have any numbers published that we can use?
Sure. So for every single platform, we publish numbers in multiple ways. So first you have the app ID throughput numbers, and then you'll have the numbers for threat prevention. I'll take an example of one of our platforms. 50-60, which we released in PAN-OS 8.0, gives you 72 Gbps throughput without any threat prevention profiles. It gives you about 36 to 40 Gbps with threat prevention. So use that data sheet to basically map out on what performance you actually need. And another thing to keep in mind is that given how many profiles you use, given how you map these to the data center, it'll vary from traffic flow to traffic flow. But typically, when you do threat prevention, there is, of course, a performance difference, but that's something we are fairly open about, and we publish it. Okay, another question over here?
Yeah. Just one question.
Yes.
How would you? What's your recommendation in protecting a guest network or something that you're not able to see it without decryption?
So there's two questions, I think, in that question. One is like, how do you protect the guest networks, right? So if someone is coming in as a guest, so this kind of goes back a little to segmentation. If you have a guest network, it should not have access to dev kind of network, right? So it's actually more of isolation than segmentation. So your guest network, there's people coming in, they have access to some resources, but it's a fairly limited set of resources. That would be one way of doing it. On top of that, you would want to have visibility into what they're doing. And then in terms of prevention, you will use all the concepts that we discussed. Any other questions? Okay, we have one over here.
I guess in a existing deployment, and I know in a new one you could put it in VLAN mode and learn some of the traffic flows, et cetera.
Right.
Existing deployment. If you're doing zero trust, how do you? Is there any kind of utility or way to sort of map that out? Without just manually looking at the traffic flows and trying to create those rules? Because I mean, you're looking at hundreds, if not thousands, of rules for that.
So the question is, how do you go about figuring out how your policy will look like based on the deployment type, if you're in vWire versus layer 3, and if there's a tool that can help you with that? Yeah. Okay, so we have the migration tool, which is now called the Expedition, which can actually help you with moving from the likes of port-based policies or the traditional approach to app-based policies. What we suggest is that we suggest a phased movement to best practices, right? So if you have those port-based kind of rules, you write an app-based whitelisted rule on top of that, but you still keep this port-based rule until you see that there is no traffic hitting it, and then you remove it. Number of rules is an interesting question. There is no short answer to how do you control the sprawl. There has to be, of course, a good balance between, you don't want your rule base to explode just because you have gone crazy about segmentation and everything, going to everything should have a rule. It doesn't have to be like that. I would actually go about using some key concepts, right? I would use tagging. Tagging is extremely relevant. If you go back to my policy examples, even if you have multiple rules, but you tag them the right way, you can still fairly understand quickly that, okay, for this kind of flow between these resources, these are my rules. Tagging is extremely relevant in understanding those rules and controlling, even if you have a fairly good higher number of rules, you can still understand the context between those rules. The other would be that you divide your resources into buckets, right? So you basically put them together instead of creating every single rule for them, depending on how you need. And you, of course, use this tool also, which will help you. Okay, other questions? Okay, I guess we don't have any more questions. Thank you very much. I hope you found this really useful. Do attend those other sessions.